this on air?
In case.
Screen share? Yeah. Thank you. Hi, I think everyone can hear me. I have zero feedback on this one. Do you want to? Hello. Okay, so hello everyone. My name is Mahesh Mohan, and I work as an ML engineer here at Google. I'll be talking about TensorFlow 2.0 and all the good stuff that it brings to the table. So, assuming that a lot of people have already used TensorFlow before. Okay, so sorry for the initial hiccups. I think now we're well past that hump. All right. So let's get started. Okay, so TensorFlow is a rather it's a toolbox that is used for machine learning in some sense, and over the past 3 years, it has evolved into a very large community, and the community is rather uh, vibrant in the sense that they have applied TensorFlow to a large number of applications. So applications range from art and music to science and medicine, and that's actually incredible that people have found such a widespread use for this toolbox. Uh, but one of the constant feedbacks that people have given us is that TensorFlow is very powerful, helps us do a lot of things, uh, but it is a little difficult to use in the sense that there's a learning curve. Uh, so one of the major things that we have focused on in bringing out TensorFlow 2.0 is actually improving the usability as far as developers and other users go. Uh, so when I say improve usability, what do I mean? So there are three major buckets which have been addressed. The first is we want to enable people to, sorry, okay. So one of the so three things. First thing is that the ability to prototype quicker. That's actually one of the key things that has been addressed in this particular version. The second piece is we need to be able to debug the models that we are building quicker. The third thing is the API over a period of time has grown large, and there's a lot of clarification, a lot of cleaning up that needed to be done. So these three are the major pieces, and I'll describe each one as we go along, and give you examples as well. In addition to all of this, there's also work that has been done in actually integrating it with all the other features that are available in the TensorFlow ecosystem. Okay, so the first thing with respect to usability is the ability to prototype your machine learning model. So if people are already aware, there's a high-level machine learning API called Keras, and TensorFlow now integrates even more tightly with Keras. I'll describe a little more about this as we go along. The second thing is eager execution. So eager execution is a way by which you can actually execute your model definitions and other things as though it were Python code, and that helps us in debugging these models significantly faster. Um, okay, so the third piece is actually removing a lot of duplicate functionality. What I mean by that is the older TensorFlow API had multiple ways of actually achieving the same function. And many a times users would come back and ask us what exactly is the right way to do it. Some of these would have almost the same effect. Some of them would have subtle differences. So it was not entirely clear what approach to use when. So now we've kind of eliminated a lot of that ambiguity. We've kind of built up a consistent and intuitive syntax across the APIs. And more importantly, we've also made it more compatible with the rest of the elements of the TensorFlow system. And that's actually very powerful. I'll give you a couple of examples as I go along. Okay, so when a lot of the talk about improving usability came up, one of the questions that remained was, if we make the interface very simple, would power users be still interested? So the good news is we are still retaining a lot of the flexibility that came with the original TensorFlow API. More specifically, there's access to the lower level API that allows you to build very flexible solutions. Uh, okay, I'll give you examples as I go along. Okay, so let's start off with one of the first pieces, which is how do you uh, build prototype models quickly? Uh, so, at its heart, Keras is a machine learning API, which enables anybody to come up and build a model without writing too much code. TensorFlow adopted Keras a couple of years ago, so there has been some integration with it. Uh, what what has happened now is that this integration has become tighter. Basically, what that means is TensorFlow took up the open source version of Keras and implemented its own version that is much more tightly coupled with all the other parts of the TensorFlow ecosystem. Okay, so what does this buy? So the idea is to address the needs of a wide spectrum of users. And by that, what I mean is, uh, let's say you are a beginner and you want to implement a model, a simple, straightforward model, and you do not want to get into the nitty gritty details of writing very detailed code. So in that case, Keras gives you a very high level API, which you can just specify the model that you want, how to optimize it, what is the loss function you want, and then just make two function calls to actually train and evaluate the models. Uh, the other end of the spectrum is a very advanced user. So, for example, if you're doing research in deep learning, then some of these standard models don't really do justice to what you're looking for. In those cases, uh, the tf.keras module actually allows you to use inheritance and interfaces and other things to actually extend the functionality that is already available by default. So technically, the sky's the limit when it comes to customizing your model. Uh, so now there's actually another concern that comes in whenever there is talk of simplifying usability. One is TF Keras, when it was considered earlier, was actually geared towards building smaller models. And one of the biggest challenges that would come up was that, let's say you do specify a model in Keras, you have built the model. Uh, how do you deploy it at scale? And that's actually one of the biggest downsides with the 1.x versions of TF Keras. So this particular thing that we are working that the changes that happened in TF 2.0 are geared towards making Keras a much bigger, much more scalable solution. Now, while retaining the simplicity and the ease of use of Keras. Uh, so, now so there are two ways to achieve this. One is called the estimator framework. What that means is estimators are a way of generating models which are kind of popular. For example, if you are interested in gradient boosted trees, or if you're interested in deep and wide networks, those are standardized models which can just be built out of the box. And once they're built, they are you can actually deploy them at scale, and you would actually have to do no real work. So it's just a single function call, and you're done. So the estimator framework is really, really useful if you want to get a system up and running very quickly. Uh, so what is the problem? There are a couple of issues. The estimator framework may not serve everybody's use case. And when it came to building customized solutions that scale, one of the problems that the community had was that things were not always very clear. I mean, it was not always clear how you could build the systems, and secondly, how we could go and deploy them at scale. So essentially, that's where TF Keras 2.0 is essentially a game changer. So basically, what does this mean for you as a developer? Let's say that this is how you would specify a model in TF1.x. So these are all using the Keras API. And what you would notice is, and this is how you would specify that in TF 2.0. Now, if you go back and compare the two, you would see that there's actually no change on your end, in the sense that the developer writes the same code. But under the hood, there's a lot of work that has happened. And the work has gone into actually standardizing how Keras deals with all, how TensorFlow deals with all the uh, underlying low-level details. Uh, so, uh, okay. So one basic thing that this particular integration, tighter integration with TensorFlow gives us is the ability to debug with eager execution. And by that, what we mean is, let's say that you are debugging. In TensorFlow, the earlier situation would be you would define a model that would end up building a computational graph. Then you'd start a session. Once you execute the session, the entire graph would get executed by the TensorFlow runtime. And that's when you kind of get feedback on whether whatever definitions you have built is correct or not. And many times, if your model is very large, the error messages would be a little cryptic to debug and find out where exactly the problem is. With eager execution, actually, you can simplify your debugging process. Basically, what you can do is you can take up the uh, code, enable eager execution, and then basically you can debug it as you would debug any Python code. So in this case, let's say you look at the dataset reading pipeline. So tf.data is a pipeline that allows you to read datasets. Essentially, now the output of this pipeline can be treated as a numpy array, which is actually very useful when you're trying to debug if there are some weird things going on with the data. Similarly, there's also another thing that will happen once you have tried to build a computational graph. So, what that means is, let's say you do define a model and you want to debug that model. You can enable this particular eager execution, and it will create a version of the computational graph which can then be easily debugged. Okay, so all right, so basically the other part is cleaning up all our API. So one of the other things that I mentioned earlier was that we were trying to clarify or consolidate a lot of the API calls that were available. By that, what I mean is we have now consolidated all the optimizers available under a single title, under a single group, this tf.keras.optimizer. And basically, it takes away a lot of the complexity. So it does not matter whether you are trying to optimize on a single machine, a single GPU, or multiple GPUs. The function call that you are going to make is exactly the same. So that kind of takes away the hassle of knowing a lot of things about the underlying hardware well in advance. So the result is a lot clean. The code is a lot cleaner. The other piece is that the interfaces have also changed a bit. Basically, what I mean by that is a lot of the hyperparameters are now just function parameters, so to speak. Uh, so there's a little bit of a benefit in terms of cleanability and readability. Similarly, all the metrics have now been collected under TF keras.metrics, and the advantage of that. So this contains a lot of standard used metrics. In addition, they also expose a bunch of classes. So in case you are not, in case you need to create your own metrics, it's easy to just subclass and then customize it to your requirement. Uh, the same goes for loss functions. So there are a lot of built-in loss functions, all collected under the tf.keras.losses heading, and basically they're also available as classes if you need to extend them. Okay. The last piece is the actual layers piece. So one of the biggest issues that happened was that layers were a little unintuitive in TF1.x. And right now, there's a lot of simplification that has happened. Uh, to give you an example, let's say you are looking at RNN layers. Uh, the problem is, in a lot of these cases, you would need to know what kind of hardware the model is going to run on before you make the corresponding layers call. So in TF 2.0, that entire complexity is removed. You make the same layers call, and what the TensorFlow runtime does for you is at the runtime, it will query the device type that you are going to use, and then come up with the um, correct layers in a manner that is completely transparent to the developers. Okay. And in addition, again, the extensibility is still open. So you still have access to the underlying classes, and you can extend it in however which way you want. Uh, of course, subject to the language restrictions. Okay, so one other piece that is interesting is what are all these? So this was so far I've been talking about what are all the pieces that we have improved with respect to the problems that we have seen before. Now, uh, we've also added integration to other tools that TensorFlow provides. One of the major tools there is structured data parsing. So let's say that you have a data set and you want to parse it with certain kinds of pre-processing and other things. Then TensorFlow provides a rich data parsing utilities. So you can actually just use those because along with the tf.keras layers. So that actually can make your pipeline a lot smoother and that can simplify the code that you write. So the second and probably the feature that I am personally very happy about is the integration with TensorBoard. The integrating your code with TensorBoard is now just a function call away. So for people who have used TensorBoard, I think they'll appreciate this. For those who haven't, TensorBoard is a way by which you can visualize certain aspects of the training and model evaluation phase. So, for example, it will give you, with respect to the training pipeline, what is the accuracy, what is the loss that comes with a particular layer, and so on and so forth. So, these are useful metrics in order to decide certain kinds of parameters. Um, so, for example, deciding between overfitting and underfitting. Sorry, that's actually one of the prime use cases. Uh, but that's actually not all. Suppose you have finished training the model and you want to deploy it. One of the biggest questions is if your application is latency sensitive, you want to know how well it performs in production. So one of the things that is necessary is to actually profile the model. And there's a part of TensorBoard that allows you to do exactly that. Basically, you take in a machine learning model, and you can actually profile which part of the model takes how much time. And that can help you identify bottlenecks. Maybe you can simplify the architecture, do a lot of other things. Uh, okay, the last piece is actually about distribution strategy. So basically, let's say that you are training a model. Now, if you are training it on a single machine, let's say that this is the code that is available. And now let's say you want to distribute it across a multi-GPU cluster. And this is the thing that TF 2.0 brings to the table is that this can be achieved in a very, very minimalistic way by just adding two function calls. And that's a huge simplification from what it used to be in TensorFlow 1.x. So to summarize, that's a lot of scalability that you get with very little modification to your original code. The another piece that is very interesting is the saved model counts. So the saved model is a serialization format which describes how TensorFlow itself saves certain models. Uh, the advantage of this format is once you have trained a model and saved it in this format, you can then deploy it on a wide variety of platforms. For example, you could deploy it on the cloud, or you could deploy it on a phone, for example. And all of this can be achieved seamlessly. There are a lot of tools available in the TensorFlow ecosystem that can help you do that. Uh, so essentially, what has happened is there's a lot of integration that we have achieved with all these other tools in the ecosystem. We've not just simplified the API and cleans things up, but we've also added a lot of integration with these other tools that can make people's life significantly simpler, both from a training standpoint and a production deployment standpoint. Now, one of the standard questions that come up is, okay, so let's say TensorFlow 2.0 has cool features and everything, but I have spent a lot of time building models in TF1.x and writing code in TF1.x. So when I upgrade, does it mean all my effort goes to waste? So thankfully, the answer in this particular case is no. There's a very easy upgrade path now. So at a very high level, there are guides that help you figure out how to reorient your code and stuff like that. Uh, let's say that you're not completely sold on the idea of moving to TensorFlow 2.0 right now. There's also a backwards compatibility mode. What that means is, let's say that you enable a flag, then all your TensorFlow 1.x code works as is. So there's a compatibility module there. So technically that means nothing ever changes for you. But let's say that you do want to harness the power that the newer features in TensorFlow 2.0 bring, then there is an upgrade script. So basically, a conversion script. So basically, what that conversion script does is it takes uh, your Python file containing the code, the TensorFlow code, TensorFlow 1.x code, and then just runs over it and does a bunch of changes, and the resulting code can then actually be used as TensorFlow 2.0 code. Now, okay, as a part of this, what exactly does it do? So there are there are a bunch of classes that have changed from TensorFlow 1.x to 2.0. It'll automatically figure those out and refactor it to point to the newer versions. Second part is there will be a bunch of keywords, flags that have changed across uh, versions. And also, there will be a bunch of function parameters that have changed. So essentially, the tool will automatically identify these and try and reconcile it with whatever it can understand. The thing is, okay, and the last piece is actually certain flags have changed. Certain options are no longer available in TensorFlow 2.0, which were available in 1.x. And this is also identified by the tool. And then in case the tool finds a function call which is not available in 2.0, it actually reverts to the 1.x version automatically. That's where the compatibility module comes in. So uh, if there isn't a specific function call in 2.0, you rest assured automatically TensorFlow will start using the 1.x version of the function call. And this is done transparently, so you don't really have to worry too much about it. But there could be cases where the tool is unable to come up with any sort of compatible solution. In that case, it will flag an error. Hopefully, those errors should be very few and far between. If you do come across something, please do send us feedback. Uh, Basically, you can go to tensorflow.org and just report this. Uh, but yeah, so the purpose of this tool is to essentially make your upgrade process extremely smooth. So ideally, all you should need to do is run this command on the command line, and the resulting file should run without hitches on TensorFlow 2.0. Okay, and yeah, so once that is done, I think upgrade process is complete. Uh, okay, so at this point, I think I will take questions. Sorry.
You can post to YouTube. Three swipes. But actually,
Sorry.
there's one question already here. You can take that.
Sorry.
The one below it.
Many times I've found normal code written with estimator and without estimator gives different output. Looks like there's some problem with the estimator API, most in case of distributed training. So one thing that I would recommend is if you have more details with respect to what kind of scenarios that comes up in, then you can just report it on TensorFlow.org. The next question I see is, does TensorFlow 2.0 compatible with TFX? I think internally TFX is geared to use the latest version of TensorFlow, so should not be a problem per se. Uh, the next question is, how does release of TensorFlow 2.0 affect the original Keras as an independent library with this integration? Uh, the answer to that is Keras, up until this point, has been an independent API specification, and there have been a lot of other backend libraries that have used the Keras specification internally. I don't think it will get affected much. So, in case there are no further questions, uh, I think we can stop here. Uh, you can always reach me. Basically, you can pick Pratyush and we can have any follow up questions you're interested in. Thank you and have a good day.